All right. Today we're going to be looking at what is the greenhouse effect, which I know we've talked about before. We're just going to kind of talk a bit more about it. We're going to review what the greenhouse effect is. You guys will work on a card sort, matching sort of descriptions with some pictures, and then you guys will work on a quiz. After you finish the quiz, you're more than welcome to work on whatever else you need to get done for this unit, or if you're already caught up on everything, you can work on stuff for other classes. All right, so starting off, we just have kind of a definition here. What is the greenhouse effect? And again, definition to help start us off. The greenhouse effect is the process through which heat is trapped near the Earth's surface by substances known as greenhouse gases. Imagine these gases as a cozy blanket enveloping our planet, helping to maintain a warmer temperature than it would have otherwise. And we've got this sort of video playing here in the background where you can see that the sun is shining, and of course that causes light to move from the sun to the earth. And let me get that started again. So sunlight reaching the earth. Some of the sunlight is just going to get reflected back. Some of it's going to be absorbed by the planet itself and then re-emitted as heat. That heat can go up through the atmosphere. However, if there are a bunch of greenhouse gases, they're going to trap that heat. And trapping that heat means that it gets re-emitted, but it gets re-emitted back in all different directions, including back towards the Earth, causing it to warm up the Earth. All right. So those greenhouse gases act to trap the re-emitted heat from the Earth, causing further heating of the Earth. And we've got this sort of image here, sort of natural on its own. Solar radiation comes in, right? That's sort of the same no matter what. The re-emitted heat, again, similar no matter what. We'll kind of not deal with too many super specific situations, but certain things, for example, snow, right, is very reflective and would cause a lot more light to get reflected back. And so there would actually be less heat that is sort of absorbed by the earth in the first place. And so as more snow melts, as more ice melts, there's less of that reflecting back automatically. Anyway, that reflected heat, again, some of it gets reflected back because of the greenhouse gases and back to the Earth, and some of that is allowed to escape out into space. Now, as we add more and more greenhouse gases, what happens is the solar radiation amount is the same, the re-emitted heat is the same, but what changes is the amount of re-emitted heat because of the greenhouse gases that reflects back to the Earth. So there's more heat that's being reflected back to the Earth, causing more heating of the planet. And of course, less heat escaping out into space. All right. Now, we always sort of talk about the greenhouse effect as a bad thing. It's not. We definitely want some heating of our planet, otherwise it would be too cold. We wouldn't want to live on it. We'll kind of look at some examples here. But there's the thing in astronomy called the Goldilocks zone. And it's not too hot and it's not too cold. It's the region near a star where liquid water can form. And if you are curious and you want to learn some more about it, there's a link there where you can click the Read More link and get some more information about it. But for our solar system, Venus, Earth, and Mars are all in the Goldilocks zone. And so we can kind of look at these three planets and they're in a very similar situation, except that they've gone to sort of different extremes, and we'll kind of look at that. Now, in terms of size, the Earth is the biggest of the three. Venus is pretty close to the Earth, and Mars is decently small compared to the other two. So we'll start off with Mars. Mars is the furthest away from the Sun. It's too small. It's not massive enough, and it has therefore lost its atmosphere to space. It hasn't been able to maintain its atmosphere. Since it has no atmosphere, there aren't enough greenhouse gases to trap in any of the heat and to regulate the surface temperatures, which means that when the sun is shining, it gets really hot or hotter, and then when the sun is not shining, the side that's away from the sun is going to get a lot colder. And so the temperature ranges on Mars from negative 136 Fahrenheit to 62 degrees Fahrenheit. So again, pretty big swings that it was recording, and this was for the Perseverance rover. Venus, on the other hand, is, yes, closer to the sun, but more importantly, it is more massive. It has more mass, and therefore, because of gravity, is able to hold on to more of its atmosphere. And Venus has been able to hold on to a bunch of its atmosphere, and in fact, it has sort of gone the opposite direction that Mars went. And it has a lot of greenhouse gases trapped in its atmosphere and has experienced what we call a runaway greenhouse effect. And that causes the planet to heat up quite a bit. And Venus ends up being the hottest planet, even though it's not the closest planet to the sun. So you might be thinking, oh, well, it's closer to the sun, therefore it's warmer. And that's not actually the reason why it's so hot. The reason why it's so hot is because of this greenhouse effect. Mercury is the closest planet to the sun, but Venus is the hottest. And the temperature on the surface of Venus is a whopping 867 degrees Fahrenheit. So if we put a bar of lead on the surface, it would just melt. So chunk of metal just completely melted. Now Earth, we are also massive enough to maintain our own atmosphere. And our atmosphere currently is between that of Mars and Venus. And so we have enough atmosphere to keep us warm and to kind of regulate our temperature a bit, but not so thick that everything is just boiling. And so we have sorry about that, didn't get to the mute button in time. We have the lowest and highest recorded temperatures on the Earth were 134 degrees Fahrenheit, and that was in a place in California, I think, and negative 128.6 degrees Fahrenheit. So again, quite a big range there, and that negative 128 was, I think, the Antarctica station. And so, again, pretty big range. But again, this kind of takes into account the fact that we have a tilt and we get some places like Antarctica that go through quite a long stretch without much sunlight. And it's, just going to be a lot colder with all the ice and everything around there. Again, notice that we're kind of looking at this range where it gets really hot and really cold, but water is in that sort of range there where we can get liquid water for most parts of that temperature range. So now you guys are going to work on a card sort where you guys are going to match up the definitions with the pictures. So the pictures with the description cards. And we'll kind of look at sort of an example here first, kind of explaining what the different parts are, and then we'll have you guys work on sorting those cards together. So the arrows show the flow of energy through the system. And so we can, again, kind of see where the arrows are pointing, and that shows you where the energy and the heat are flowing through the system. The blue arch on top, that's sort of to show the greenhouse gases in the atmosphere. And so you can kind of have an idea about how thick it is, how much greenhouse gases there are, and things like that. And then the thermometer on the side is showing the temperature. So again, those clues should help you kind of figure out which cards go with which situations. So go ahead and pause the video here, spend some time working on that card sort. When you guys all agree as a group, what you guys think the correct matchings are for the cards, go ahead and jot them down in your notes. Just on a separate piece of paper is totally fine, so that everybody has a copy of what things should look like when they are done. All right, so hopefully you've finished your card sort. We're going to go ahead and take a look at the solutions before you guys work on your quiz. So here are the solutions for our card sort. This first one is looking at CO2 is decreasing. So a country switches to solar, wind energy, plants millions of trees, and reduces car emissions by improving public transportation. And that is paired up with this picture above it, where the temperature has dropped a bit. They're thinner, meaning fewer of those greenhouse gases, and a lot of the heat is allowed to escape through and get out into the atmosphere and out into space. This middle one here pairs up with the average, CO2 average. Country is using some renewable energy but still uses some fossil fuels. So some energy is getting reflected out into space, and some of it is getting sort of reflected from the greenhouse gases back to the Earth. This next one is where CO2 levels are increasing. Cities adding more highways, encouraging more car use instead of public transportations. Factories are also producing more production and therefore more greenhouse gases. And again, you can kind of see that more of that is getting reflected back by those greenhouse gases and trapped in the earth to heat up the earth further. And this last picture here is sort of this generic diagram, greenhouse effect diagram, shows long-term change in the Earth's average temperature based on reflections of sunlight and trapping of heat by greenhouse gases. So that's sort of just a generic model. Again, not always a bad thing. If we didn't have it, we would be freezing. So we need to have some greenhouse gases. We need to have the greenhouse effect to help us maintain our temperatures and avoid too drastic of a swing of temperatures. But of course, if we let it go too far, then things could get worse and worse, and we could end up with a runaway greenhouse effect the way that Venus has. And we don't want that either. So, got to stay right in the middle in the Goldilocks. All right, quiz time. Do the best that you can. Make sure that once you start the quiz that you finish it and that you don't close out the window or anything like that.